Hey everybody, Doug here. I wanted to present a video here today where I talk about the performance and value of different SD cards that are out there and kind of talk a little bit about some of the technologies that are involved and some of the terminology to help people understand what you're going to be looking for when you need to go purchase an SD card for video or film work. And those of us who work in video and film very often are using SD cards to record video and audio or whatever. And we want to make sure that we have cards that are able to keep up with the needs, keep up with the speeds that are required to save video. And it's difficult to kind of make sense of all the stuff that's going on out there, particularly because a lot of manufacturers tend to, shall we say, exaggerate their performance ratings and or hide the meaningful, the data that actually is useful when determining what cards to actually purchase when we need to stick one in a camera or a video recorder of some kind. So I've spent more time preparing for this video than I have any other, with one exception on this channel. All the cards that you see in here in front of me, I've done exhausting testing on. Not just these, but a bunch of other ones as well. These are just kind of the highlights. And the data that I've come up with here is actually very useful when making purchasing decisions so that we know we're actually getting something that's going to meet our needs. So first of all, I want to talk a little bit about terminology when it comes to SD cards. So if you look at the front of an SD card, you're going to find different sort of markings on there. So I'm going to take a look at this one right here. So this is a 512 gigabyte one from Lexar. This is rated at 160 megabytes per second by the manufacturer. They also have a speed rating here that's 1066x. That number is more or less meaningless these days, so I would kind of ignore that. But over here we've got some other markings. So SDXC, that is the type of card. SDXC is what we're going to have with cards that are 64 gigabytes and larger. Anything smaller than that's going to be SDHC these days. Not that meaningful when it comes to performance. Next to here we have something that's called V30, and what that is, that's a rating by the manufacturer. It's basically saying we're going to guarantee that this card is able to write at least 30 megabytes per second consistently across the entire capacity of the card. You'll also find other ratings as well, V10, V60, V90, and again, that's just the number of megabytes per second that the manufacturer guarantees for writes. That doesn't mean that the card can't go faster, and in fact, in most of my testing, the cards were considerably faster than that. So as we look at data here, you'll see that a lot of the cards are V30, but are capable of writing a whole lot faster than that, in some cases over 100 megabytes per second. There's other ratings on here as well. There's this little I on here. What that means is UHS Type 1. There are also UHS Type 2 cards as well. And that's a speed rating. Again, that's basically the communication speed between the card and the computer that you plug it into, or the other device. You can actually very easily tell if a card is UHS 1 or UHS 2 by looking at the back. So you look at the back and you have a single row of pins like this. That means it's a UHS 1. And pick up this one over here, and this is a UHS 2, and you'll see that it has 2 rows of pins. Those additional pins are what make it so the card is able to communicate quite a bit faster, basically 3 times the speed of UHS 1. So if you're looking for the fastest cards, you probably want to get one that's UHS 2 rather than just UHS 1. All right, now we're going to find that some manufacturers sort of exaggerate their performance ratings a little bit. So I'm going to take a look over here at this one from SanDisk. So you see on the label here it says 200 megabytes per second, but if we take a look at the flip side, it's only UHS Type 1, which means that we pop this into a standard reader like you would have in your laptop, or you purchase at your local retail store or whatever, or like I have here. This is my StarTech reader that I use. This is it has 4 card slots in it, and if you pop this card into that, you're not going to get more than 100 megabytes per second. In fact, this card actually tops out more like 95 megabytes per second in those readers. Now, they're not entirely lying here. So what they've actually done is they come up with their own reader, and you pop this card into that reader, and you're able to get speeds that are much closer to that. It's not quite 200 megabytes per second in this case. It's more like 170, but it's a lot faster than the 100 megabytes that you normally get with UHS Type 1. So what they're essentially doing is they're sort of breaking the standard. They're doing their own thing in order to get those higher speeds. The downside to that is that those speeds are not going to be achieved in any other type of device, like a camera or a card reader that's in your computer. If you want those higher speeds, you have to use their reader. SanDisk is not the only one who does this. Have this reader from Lexar as well, and this is able to achieve higher speeds with their cards as well. So, for example, this card is 160 megabytes per second. Again, UHS Type 1. but I pop into this reader and it's actually able to read faster than 160 megabytes per second. The funny thing about that, though, is this Lexar is able to achieve speeds that are higher than UHS 1 for other manufacturers as well. I found that I was able to get the 170 out of the SanDisk on this reader, as well as some higher speeds on some of these Samsungs and whatnot as well. So if the highest performance for your computer is what you want, you might want to invest in this Lexar reader. There's a link popping up there on your screen for that as well. The downside, of course, is that those higher speeds are not something that you're going to be able to achieve by using the reader that's built into your computer. Now, UHS 2, like I showed you here on this one right here, the speeds on that are, again, upwards of 300 megabytes per second, and I was able to achieve those speeds on StarTech, on Lexar, and several of the readers and laptops that I tested as well. Not all, but I found that most like higher-end laptops are able to achieve the higher speeds that are associated with UHS 2 as well. Now, when I say I tested these things, I mean I tested them pretty thoroughly. I tested them in multiple readers on multiple different computers, and in order to see what real-world speeds we can actually expect out of these things. So I wrote my own software to do this. It's something I wrote years ago, and it's available for free for anybody else who wants it. But I was able to determine what real-world speeds are achievable, not the maximum ratings. So basically, the software reads and writes every single sector on the disk from start to end, and that way we're able to know what the real world speeds are, and those are available on my website. So let's actually take a look at that, and you'll be able to see some of the data that I've collected. This is a free tool I have on my website. Anybody can go here. So the easy way to get here is djp.li/cardperf, which is short for card performance. And I've tested multiple different types of media, but I'm concentrating on SD cards here today. So the data is presented in a format like this. So we're able to, for example, click on one of these things and gather more data about one of these devices. Now, what the data that I've collected, so we've got read speeds and write speeds. Again, this is tested across the entire media. You find that we've got maximum speeds here, we've got minimum speeds, average, standard deviation, 99%, which is basically the speeds that are achievable 1% of the time. The numbers are a little bit backwards. And then we come over here to the 5% number, and you notice those are bolded. And basically what this means is like 95% of the time, or less than 5% of the time, these are the speeds that this card is able to achieve. You see here that this is actually in the Lexar reader. This is a UHS 1 card, and you notice that these speeds here are well over that 100 megabytes per second. That is because this reader is able to achieve speeds that are greater than normal on UHS Type 1. Now, the other thing we've got here is we've got this little chart, which basically shows the speed from start to finish. Blue is read speeds, red is write speeds. You can see that for some reason, periodically, the write speed actually drops a little bit. Now, if it does it occasionally like that, that's probably not really a problem. But if you look at one of the graphs here on my website and you see that there's a lot of drops in there, you might want to steer clear of that card if you're going to be using it for video, where you've got a device, a camera, a recorder, or whatever, that's consistently writing a lot of data at high speeds. So what you don't want to get into is a situation where the card is not able to keep up with the data that is coming out of the camera. At that point, you'll start dropping frames, and it makes it much harder to synchronize during editing, and those glitches can be very noticeable. So we want to make sure that we're picking a card that's going to be able to keep up with the device that it's plugged into. We'll back up here and look at one that's actually using UHS 2. This is one from Team Group. This is a 256 gig SDXC from their Extreme series. It's a 256 gig card, and we can see here that the performance is actually fairly consistent from start to finish, and the speeds here are actually much higher than the manufacturer rated. So the manufacturer rates at 250 megabytes per second for reads, 120 megabytes for writes, and is able to achieve 269 for reads, 177.6 for writes. So this card is consistently faster than what the manufacturer claims, and I found that in some cases there are manufacturers that are that way. Team Group seemed to be the one that was the most conservative in their ratings, and SanDisk was the least accurate of any of the ones that I looked at. There's a few other things you might notice on here. So I've obviously got a picture of the card. When the manufacturer still has a web page associated with a product, I've got a link to that here. And then in the upper right, it can show the Amazon price, and there's a link to purchase that now. You can see when that price was last updated. My site actually updates those prices approximately once per day, so you can always know that the pricing there is going to be consistent. Down below, there's actually an explanation of what the numbers mean, a little bit of information on how you can use that information, and then the 2 card readers that I recommend that I had the best luck with, so the links to those there as well. So you can click on these images or the links here in order to go to Amazon to find those. Now, this tool allows you to do a lot of filtering and sorting on the data, so you're able to find the data that you're looking for. So say, for example, we want to shop for a 128 gigabyte card, so we'll just select that size here. SD card is already selected. We're going to sort by performance value, which means that you get the most performance for your dollar. And I'm going to go ahead and click on view, and here we go. So now we're seeing 128 gig cards sorted with the most performance for your dollar up top. And right now you can see that the Samsung Pro Plus is up at the top of the list. But you also notice that's on the Lexar reader, which again, if you don't have that, you're not going to be able to achieve those speeds. So I've got a thing here that says let's only view tests that were performed on the standard reader. So I'm going to click on that and then refresh the results. Now we can see that the PNY Elite X 128 gig SDXC card, this one right here, is able to achieve the best speeds for the dollar that you're spending here. Now this sort order is actually going to jump around quite a lot. So as you're watching this video, you'll probably find that this order that you're seeing here is very different than when you go to visit the site after you watch this video. And the reason for that is the prices are constantly changing. I noticed that some of these things are jumping around a lot. Up to the time that I started shooting this video, the team group cards, the Pro and the Extreme, were up at the top of the list, but their prices actually went up this morning, and so they've actually gone down in the list. So just bear in mind that what you're seeing here today isn't necessarily what you're going to see when you go to visit this site on your own. The other thing I've got here is I've got the ability to set minimums. So say, for example, we want to take a card and use it in one of the Blackmagic HyperDeck recorders, and we're going to be recording at 1080p, 60 frames per second in ProRes. We want to make sure that we're going to be able to write 60 megabytes per second for that. So I'm going to enter that for the minimum write speed, and then I'll click on View. And now we'll find that this list is filtered by only the cards that are able to keep up with that 60 megabytes per second limit. And then from there, we can make our buying decisions. Now, it's kind of important to know what minimum speeds are required for whatever you're trying to achieve. One of the easiest ways to do that is to take a card that you know is fast enough, record a bunch of video that's got a lot of motion, a lot of detail at that frame rate, at that resolution, at that particular codec, record for, say, an hour or a half hour or whatever, and take the size of the file and then divide that by the number of seconds, and you'll be able to be able to see what your average speed is. And then you're going to want to give yourself about another 20 to 30% headroom on top of that. And that headroom is there in order to make sure that when there are additional higher bursts, that the card is able to handle that and not drop any of the frames that are being written. Now, I've got some other things that you can sort by here. So if, for example, you want to see the overall fastest cards, or let's do fastest writes. So we'll look at all the cards that have the fastest writes regardless of price. We can see here that this Lexar Professional 128 gig 16167X SDXC 250 megabytes per second UHS2 is the fastest of the cards that I've tested, fastest writes in the standard reader in the 128 gig size, and that's able to achieve writes of 103 megabytes per second. Now we'll just clear this out here so we can see all of them, but that won't affect the numbers at all. We can also see that the Team Group Extreme is able to do 96 megabytes per second. If we, for example, want to see all sizes, I can change that. I personally use 256 gig and 512 gig cards for most of the things that I do, and so there's a kind of a bias in the data that's being tested here. But we can see that, for example, the fastest cards I have are actually 64 gig from Lexar and SanDisk. And you're able to see that those are able to achieve write speeds that are 200 megabytes per second and up. So you also see that the Team Group Extreme 256 gig is also a lot faster on writes than the 128 gig card. So it isn't necessarily true that the card in a particular series is going to have the same speed from one capacity to another. In fact, I found some situations where it was not that way. For example, this PNY Elite X 512 gig card, this one only consistently writes about 30 megabytes per second, whereas the 256 and the 128 are able to achieve more like 80 megabytes per second. So you have to kind of research on the exact model of card that you're going to be purchasing in order to find out what the actual performance is. The performance isn't necessarily consistent from one capacity to another. Now, if you're just coming to this video to find out what card should I buy if I'm working in video, and say, for example, I'm using a HyperDeck device in order to record video. Well, I'm going to direct you to my website, but as of the time I'm filming this, the Team Group Extreme 256 gig SDXC V60, this card right here is the best performance value that is currently offered. That card is $60. That card is able to achieve 178 megabytes per second on writes and 270 megabytes per second on reads. Those are speeds which are achievable on most devices which are UHS-2 compliant, which includes the HyperDecks. So you buy that card, you know it's going to be plenty fast for any of the video that the HyperDecks are capable of recording. So if you want something that's relatively inexpensive and it's going to give you a lot of good performance and good reliability, right now that would be my recommendation. In the past, I've recommended the Lexar 256 gig, 250 megabyte per second SD XC in UHS-2, and those have been fantastic cards, and I still love them, but the price on those has actually gone up considerably. Those cards, at the time I'm recording this, are now $73, whereas in the past they've been as low as $55. So if you're looking for the best performance value, the Team Group Extreme 256 gig model is currently the best performance that you can get for your money. The PNY Elite X and the 128 gig and 256 gig are also great cards for the dollar, but the 512 gig is not. It runs a lot slower than the others. The other ones that I found to be great values are the Samsung Pro Plus. I have that both 256 and 128 gig, and the Team Group Pro and 256 and 128. Those are also great values as well. So any of those cards are going to be able to give you a lot of performance for your money if you have to be concerned about the purchase price on one of these media, but you need something that's actually going to be decent performance. So anyway, there you go. I've put a ton of time into testing these things. I've been working on this video for weeks and weeks and weeks, and I also obviously purchased a whole bunch of different cards in order to achieve this. I did purchase all of these. None of these were provided by the manufacturers. None of the manufacturers knew I was doing this. They're not aware of it, so I want to try and be as unbiased as I possibly could. And again, I did test these in multiple readers on multiple different computers to see if the performance that I was seeing was consistent from one device to the next. And for the most part, I found that that was true as long as I was using high performance readers as I was doing that testing. Now, I've kind of already mentioned this, but the readers that I actually really like quite a lot. First of all, this StarTech. This one is 4 slots. It allows you to copy 4 cards at a time. It uses USB-C. It also comes with a USB-A cable. And as long as you plug it into a USB port on your computer that's capable of 10 gigabits per second, you're able to actually read cards at up to 10 gigabits per second. What that typically means, though, is you're able to do 4 cards at 250 megabytes per second, and it's able to keep up with that just fine. So this has been kind of my go-to. I have several of these, and these is what I use most of the time when I'm copying cards from cameras into computer after the end of an event. Now, if you want the best performance, though, this Lexar reader that I mentioned earlier seems to be the best performing of any that I've tested. Previously, I recommended a model from Kingston, and that's still a decent model, but I found that the Lexar is actually quite a bit faster for the non-standard cards like the SanDisk and the Lexar that I mentioned earlier, and the Samsung as well, which are able to achieve speeds that are higher than UHS-1 normally can. So if you want to be able to get the most speed from those cards, this Lexar reader is going to be the way to go. It's actually particularly inexpensive as well. I picked up this one for $13, and they seem to be going for that fairly consistently. And this has both SD and micro SD on it as well. So although it is just 1 card at a time, so if you need to read multiple cards, you either need multiple of these and plug into multiple USB ports on a computer. I would actually stay away from USB hubs. You're not going to get consistent performance out of a USB hub, particularly because there's very few that are able to do 10 gigabits per second like the StarTech reader is able to do. So if you are reading multiple cards at a time, either get these and plug them directly into your computer. They do have a USB-C version of this as well. Either get multiple of these and plug them directly in your computer, or get this StarTech reader that I recommended just a moment ago. The other thing I want to mention is you should probably read the documentation for the devices that you happen to be using to see if they actually support UHS Type 2. Not all do. This camera that I'm shooting on here right now, the Sony V90, actually requires UHS Type 2 when you're shooting in 4K, so it definitely supports it. Blackmagic HyperDecks, at least the newest models, all support UHS 2 as well. Some computers do, a lot of higher-end computers do, but if you want the most performance, you probably want to avoid using the reader that's in your computer, because the manufacturers of most laptops tend to kind of cheap out a little bit on the components, and you're not able to get the best speeds out of those devices. So that's going to about do it for now. So thanks everybody for watching. If you have any questions about this, you can leave those in the comment section down below, or even better, join us over on Discord. A link to my Discord server there is popping up on your screen right now. There's a huge community, hundreds of people who work in video production and are there to help and answer questions. It isn't just me. There's lots of people there who work in video production as well. If you want to download this software tool, the DJ Drive tool, it's available as well for free, no charge. That's djp.li/drive tool. You can get that and use that all heart's content. I don't charge anything for it, nor will I ever charge anything for that. So, okay, that's going to about do it. So if you're new to the channel, please consider subscribing. I try to do video production related content about once a week. I'm a little off schedule recently, but I'm going to get back on it. I've got some great videos coming up. I've got one coming up where I actually demonstrate how to get the output of a Macintosh, a Mac computer, into a video production system, which has been a kind of a headache the last couple of years, but I've got some answers. I've got some things figured out there, so stay tuned if that's something that you're interested in. I've also got some other videos in the works as well. If you want to see some additional content, including behind the scenes for events that I happen to be working, you might want to sign up for the YouTube membership program. So there's a join button down below, or join us over on Patreon and make a contribution over there. So I do post extra videos there fairly regularly. You also get additional bonuses as well, for example, a free membership to my crewaccess.com video production management site, and you actually save money compared to buying the plan on there directly. So if that's something you're interested in, be sure and sign up for one of those programs. So that's going to do it. So thanks everybody for watching, and have a fantastic day.